Hi everyone, I'm going to show you how to do a couple of the problems that were on this Gravitation and Kepler's third law math practice worksheet. So I'm going to do question number 1 with you in the gravitational equation section. So it says, determine the force of gravitational attraction between the Earth, and they give you the Earth, we'll call the Earth mass 1, 5.98 times 10 to the 24th kilograms, and a 70 kilogram student. We'll call that mass 2. So determine the force between the two masses if the student is standing at sea level, and they tell you sea level is a distance of 6.38 times 10 to the 6th meters from the center of the Earth. And then another known value, the equation is the force of gravitation is equal to g, the gravitational constant, times m1 times m2 over d squared. So another known value is g, 6.67. It's a constant, it's always the same number, times 10 to the negative 11th. Now, you can start plugging into your equation with your known values to solve for f. I usually take out the units when I'm plugging them into the equation and add them in at the end. So f equals g times m1 times m2 divided by d, and don't forget to square. So instead of plugging all of this into the calculator at one time, I would break it up. I'd do my numerator, solve for the denominator, and then divide the two. So I'm going to show you how to plug these numbers into this calculator, but if you're using the online Google calculator, that's fine too. But either way, I would put these numbers in parentheses. I'd be smarter than the calculator. Okay, there's my numerator, so I end up getting 2.79, I'll round to the hundredths, times 10 to the 16th. And now I'm going to solve the denominator, 6.38 times 10 to the 6th, put that in parentheses and square it. 4.07 times 10 to the 13th. Now I can divide the two. 2.79 and I get a force of gravitation of 685.5 newtons. All right, so that's an example of using this equation, universal law of gravitation. So the next one I'm going to do is for Kepler. In the next section, it starts over with problem 1. So I'm going to do problem 2, but in the second section. It's a question about a dwarf planet discovered beyond the orbit of Pluto. It's known to have an orbital period. Orbital period is represented by P of 619.36 years. And we need to solve for A, which is the average distance from the sun. The equation for Kepler's third law is P squared equals A cubed. So let's plug in our values here. P is 619.36. I'm going to have to square that, and that's going to be equal to A cubed. So 619.36 squared is 383,606.81. Now, the reason why I chose number 2 is because you're solving for a cubed value. So in order to isolate this A, if it was, let's say we're solving for P, we would take the square root. But when you're solving for A, you take, it's called the cubed root. So it's going to look like this, a 3 with your square root sign, All right, that's how we isolate A. So I'll show you how to solve that on the calculator first. If you have this calculator, it's a little different on every calculator, but I think most of us have this one. It's this button right here, the caret. It's the second function of the caret. It's a button that looks like this. So what you do is you hit 3, and then second caret. That will put the 3 in the little x spot, and then you do 383, 606.81 equals. So A is 72.7, and then A is measured in AU, capital AU. That's the average distance from the Earth to the Sun is 1 AU. So this dwarf planet is about 73 times the distance of the Earth to the Sun. So if you're using a calculator on the computer, you can type into Google cubed root of, and then this number, and Google will solve for you. So if you're not using a calculator this year, that's the other way to solve it.